Alright, we're going to do a little bit harder example this time. If you need to go back and repeat the first one, please do so before you attempt this one. If you think you want to try it before you listen to me, go ahead and press pause and see what you can do. I'm given a cubic polynomial. We can see that with our third degree. The difference here is that notice my root is not a real number. I've got a complex number, 3i. Okay? I have a total of 3 roots that I want to find. I've been given 1. One nice thing about giving complex roots is that they always come in pairs. So if they've told me 3i is one root, then the conjugate of 3i, which is negative 3i, is my second root. So right away I've been given 2 of the 3 roots. So the trick is going to be finding that remaining root. Okay, so I'm going to take a little bit of a different approach here. Rather than doing synthetic division with imaginary numbers, which wouldn't work out too well, we're going to go ahead and turn our 2 roots back into factors, turn our 2 zeros back into factors, multiply them together. That's going to give us a quadratic, and then when I can divide that quadratic into my cubic, I'll get the remaining factor, which I can solve to find my remaining 0. Okay, so the first step here is to turn these 2 roots back into factors. And remember, a root is a solution, so I can just say that's really what x equals. X equals 3i and x equals negative 3i. If I make each of these equal to 0 by subtracting, oops, it's going to come up plus 3i. Okay, I've turned my 2 solutions into factors. So we will write them as factors, and we know if we multiply them together, we will get a quadratic. Alright, so that's what we're going to do. We're going to FOIL. So we multiply our first 2 terms to get x squared. Our outside terms will give us plus 3ix. Inside terms, negative 3ix. And our last 2 terms, a negative 9i squared. Now, we talked about this last semester too, but the beauty of multiplying conjugates is that the middle 2 terms always cancel out. So you can see right away that my negative 3x and positive 3x, when I add them together, will result in 0. So those disappear out of the problem. I also remember that I squared is really negative 1. This is leaving me with x squared plus 9. So this right here is a combination of 2 of our factors. It's incorporating 2 roots, 3i and negative 3i. If I take this and divide it into my original polynomial, then I'm able to find the third factor, which I can change into the third root. Alright, the problem here, this is not a linear binomial, this is a quadratic, so I'm not allowed to use synthetic division. I've got to go back to long division, which is why we reviewed that with you. So let's set up our long division problem and divide. Alright, we ask ourselves, what do I have to multiply x squared by to get x cubed? That's just going to be x to the first. Multiply back through both terms and subtract. Remember, we're subtracting this whole thing. So x cubed minus x cubed is 0. 2x squared minus 9x. Forgot my... Oh, you know what I did? And this can come up. Notice my divisor here does not have an x term, okay? So when I went to multiply, really what I should have done is I should have scooted that 9x over here, right? To line it up so everything like terms. And this is really a 0x squared. And that's okay in long division. It's not as important as it is in synthetic to put that placeholder in, but you just have to be careful that you don't accidentally add terms that aren't alike. Alright, so really I'm saying 2x squared minus 0x squared. And then I have 9x minus 9x. So that's going to give me the 0x. Bring down my 18. Okay? Repeat the process. How many times does x squared go into 2x squared? What do I have to multiply it by? Just a 2. Multiply back through. I don't have an x term. And then I have 18. Subtract that whole thing. We get a 0 remainder. The remainder theorem holds true even in long division. So x plus 2 is our quotient. X squared plus 9 is a factor. We knew it would be because we started that way. And what we found then is our third factor. X plus 2 is our third factor. Okay? So if we change that into a root, we just set it equal to 0 and we solve. So negative 2 is our third root. We were given 3i. We knew that its conjugate was also a root, and we just solved for the third one. Again, we double check. We started with a cubic, so we knew we were going to get 3 solutions, and here they are, 1, 2, 3.